All right. I'm just going to make a little addition to the video showcasing how to do the exercise analyzing the derivative graph level 2. So I think like the level 1s that we did 2 skills ago, you want to make sure that you are translating like the terminology into kind of plain English. So what we have here is the graph of f prime. So not the graph of f. So this is the graph of f prime. And we have to make some inferences. So we need to determine all the intervals for which f of x is concave up. So here's what concave up means. It means that f double prime of x is positive. And it also means that f prime of x is increasing. Now, we have the graph of f prime of x. So this statement here, f prime of x is increasing, is useful. So what this is asking for is, when is this graph increasing? So just by having a good read of like the directions on here, we're able to take something that seems like a tough calculus problem and translate it into, you know, a pre-calculus problem, like what you had last year. So this is the graph of f prime of x. And we know that concave up means that f prime of x is increasing. So that's what we're looking for. So if I'm going to kind of look at the intervals for where we are increasing, so right about from like, I could even like trace the graph. It looks like right about there is where we stop our increase. So we have, you know, some concave up type of thing going on in that interval. And then right about at -1 to the 1, so this part of the graph is definitely increasing. And I'm just going to kind of be like the solution on delta math here. And between 6 and 9, we're increasing. So I'm just going to write the intervals. So I have -9 to -5. I have -1 to 1. And then I have 6 to 9. And I'm just going to go ahead and put those intervals in. Make sure that my x values are looking good. And I submit. And you can kind of see in the solutions, they do help you kind of with the interpretation. And they actually do give you the graph of f double prime as well as the original function as well. Another type of question that you may see is determine the values of x, if any, at which the function f has an inflection point. So what inflection point means is that f double prime of x is equal to 0. And this is where we're going to be looking for our f prime of x having a local min or local max. And there's one such point there. So right at, and when we're still having the graph of f prime, so right at 1 is where that is occurring. There's no local min. And let's just try this out. So, and it does nicely say that f has an inflection point when f double prime changes signs, or when f prime has a relative minimum or maximum. So that's your guide to function analysis. So what I really encourage you to do on all these questions, instead of being stuck with like f's and f primes and f double primes, really work on translating them into plain English, because you can actually turn a calculus problem into something that's a lot easier, and having those more specific directions. So if you want to talk it out with me in an interpretation and breakout room, feel free to let me know, and I'll be happy to work with you.